Now let's look at the characteristics of covalent and ionic bonds. Remembering that covalent bonds occur between two nonmetals sharing electrons, and ionic bonds occur when a metal gives a valence electron to a nonmetal. So it's the actual transfer of electrons. Covalent is sharing, ionic is transferring. So when you look at covalent bonds, because they are gases, they have the characteristics of gases. So they have very low melting and boiling points. They're softer and squishier. Gases are always more flammable than your solids. Not soluble in water, which means that they don't dissolve in water. And you know that's true. I mean, if you've got a soda, it's got gas in it, bubbles, and you know it doesn't dissolve well. And gases do not conduct electricity very well. While ionic bonds consist of a metal and a nonmetal, so therefore ionic bonds tend to have the properties of metals. So they have high melting and boiling points, just like metals do. They are hard and inflexible, and the reason why that's so is because they're, again, has at least one metal. They're less flammable than your covalent gases. They are soluble in water, and again, soluble means dissolvable, so they will dissolve in water. And all metals conduct electricity in water. So because ionic bonds have metals in them, then they have the characteristics of metals, while covalent bonds are made of two nonmetals, typically gases, so they have all the characteristics of gases. Now let's look one more time at what happens with a covalent bond first. So you've got these two atoms and they come together and they are literally sharing electrons so that they can have a full outer shell. While in an ionic bond, you have one atom, a metal, that gives away or transfers an electron to the nonmetal. And when that happens, that metal becomes a positive ion because it has more positives in its nucleus than it does electrons in its energy level because it gave one away. And then the nonmetal becomes a negative ion because guess what? It gained an extra negative charge in the form of an electron. So there's a transfer here. Now let's look at metallic bonding, the properties. We know that metallic bonds occur between two or more metals. So they're going to have the properties of metals. They have high melting and boiling points. I mean, you know it takes a lot to melt a metal and an extremely high temperature to boil a metal. Metals always conduct electricity and heat. They're hard and they're very dense. You know, a gas in a covalent bond, those gases don't have very much density. Their particles are all spread out. But when it comes to metals or solids, they're very packed and tight, so they are super dense. Metals, again, can be hammered into shapes, so they're malleable, and they can be drawn out into wires or have ductility. Now let's talk about the strength of these bonds. So the strongest bond, of course, are your metallics. When they're sharing all of those electrons with every nucleus that's in the bond, that pulls them together really tight and they're very strong. Followed by the second strongest bond, your ionic bond. Again, it has a metal in it that gives away an electron to a nonmetal. And finally, your weakest bond is your covalent bond because you have these nonmetals that are sharing these electrons, and so they're not super tight with the nucleus, and that makes them very weak. So finally, just in review, ionic again, you have a cation, a metal that gives away an electron to your anion or your nonmetal. And then in covalent, there's sharing They're basically sharing one electron each. Each nonmetal is sharing one electron. In a metallic bond, you have a bunch of metals. Their nucleus are sharing all of the electrons randomly. And of course, these types of covalent metallic bonds can create these giant molecules, and a lot of sharing is taking place.